Hey everyone, this is the Math Nexus, and today we are going to continue with exercise 2.1. We have discussed the main concepts and the main things we need to know about this exercise in the previous lectures. So I'll just start immediately with question number 19. We have to finish this up by the end of this lecture. So question number 19. And what we have in this question, they are asking us to calculate the coordinates of the point where the line y is equals to 1 minus 2x cuts the curve x squared plus y squared is equal to 2. And the thing they are saying is, and by the way, this is a rough approximation, it's only for your visualization. This is not how this could be. It could be something else. But I'm just showing so that you can easily visualize. And the thing they are saying is that there's a line which is cutting a curve at a point, and we have to find that specific point. And we have to find actually the coordinates of that point. So the thing is that we can say at this point, the equation of these two lines, 1 minus 2x and x squared plus y squared is equal to 2. They are the same because the coordinates are the same at this point. So we can say that x squared plus y squared is equal to 2 and y is equal to 1 minus 2x are internally connected. And so we can input each of these values into one another. So it's simply, again, we are going to mark this as equation 1 and this as equation 2. Okay, now we will input equation 2 into equation 1. And that will give us x squared plus, instead of y, we are going to write 1 minus 2x squared is equals to 2. And that's it. Now what we're going to do is simplify this x squared plus a squared, meaning 1 squared, minus 2a, meaning 1, b, meaning 2x, plus 2x whole squared is equals to 2. And simplify this further, x squared plus 1 minus 4x plus 4x squared is equals to 2. And 4x plus 4x squared, so 5x squared minus 4x plus 1 minus 2 is minus 1 is equals to 0. And what we're going to do is use the quadratic formula. A is equals to 5, B is equals to negative 4, and C is equals to negative 1. Now that will give us minus B, meaning positive 4, plus minus under root B squared, meaning 16, minus 4 multiplied by 5 multiplied by negative 1. Divide this whole by 2 multiplied by 5. And so 4 plus minus 16 plus 4 5 is 20. So 16 plus 20 is actually 36 divided by 10. Now that will give us 4 plus minus 6 divided by 10. So x is either equals to 4 plus 6, meaning 10 divided by 10, or x is equals to 4 minus 6, meaning minus 2 divided by 10. So 10 divided by 10 is equals to 1, and 2 and the 2 to 5 to 10. So that's equals to minus 1 upon 5, which can be said as minus 0.2. And for the corresponding y values, we have y is equals to what's y? Y is equals to 1 minus 2x, so 1 minus 2 multiplied by 1, or y is equals to 1 minus 2 multiplied by negative 0.2. So y is equals to 1 minus 2, which is 1, or y is equals to 1 minus 2 multiplied by 0.2, which becomes 1.4, because 1 plus 2 multiplied by 0.2. Negative and negative will be multiplied. So we have these two values, and thing is, we can say at 1 and negative 1 are points intersect, and at the point negative 0.2 and 1.4 are points intersect. That means this graph is not intersecting at 1 point but 2 points, something like this. I know it's rough, but it's just for clarifying the concept. So this is for question 19, and let's proceed to question number 20. Okay. So in question 20, they have told us to find out the sum of, we have the sum of two numbers x and y is 11, and the product of two numbers of these two numbers x and y is 21.25. And what they have told us is to write two equations in terms of x and y, you can see. And they are giving the information about these two equations in the question itself. So the sum of two numbers x and y. So we can say x plus y is equal to 11. And the product of two numbers. So products means multiplication. So we can say if we multiply x and y, xy is equal to 21.25. And that's it. These are the two equations in terms of x and y. We wrote them down. For part B, we have solved the equation to find the possible values of x and y. So for that, what we do is, this is equation 1, this is equation 2. And we have to find out equation 3. We say y is equal to 11 minus x is our equation 3. Okay. And then we input this, input 3 into 2. So we get x multiplied by 11 minus x is equal to 21.25. Okay. So we'll have 11x minus x squared is equal to 21.25. And we'll just simplify this. Take this 11x minus x squared on the other side to make x squared positive. X squared minus 11x plus 21.25 is equals to 0. So now what we are going to do, as you can guess, the quadratic formula, and this is going to be the last one I'm going to solve the quadratic equation along with you. Next time I'm going to use calculator. A is equals to 1, B is equals to negative 11, and C is equals to 21.25. Okay, input this into the quadratic formula, so we will have minus b, meaning minus b will become positive 11, plus minus under root b squared, meaning 11 squared, which is 121, minus 4 multiplied by a, meaning 1 multiplied by 21.25, divided by 2 multiplied by a, which is 1. Simplify this up, 11 plus minus under root 121. 4 multiplied by 21.25 is 85, and as this is negative 85, we are going to subtract 121 minus 85 is equals to 36. So 11 plus minus under root 36 divided by 2, and further simplifying 11 plus minus under root 6, sorry, only 6 divided by 2. So what we'll have is x is equals to 11 plus 6, meaning 17 upon 2, or x is equals to 11 minus 6, meaning we have 5 upon 2. So we have 17 upon 2 is 8.5 and 5 upon 2 is 2.5. For the corresponding y values, we are going to get y is equals to what's y? Y is equals to 11 minus 6. So 11 minus 8.5, or y is equals to 11 minus 2.5. So y is equals to 8, y is equals to 2.5, or again y is equals to 1.5. And I'm sorry, 8.5. I don't know where's my brain going up. So we have two coordinates again. When x equals to 8.5, y is equal to 2.5, and when x is equals to 2.5, y is equals to 8.5. These are the two coordinates which have the possible values to the equation. That's it for question number 20. Let's proceed to question 21. Okay, for question number 21, we have the question given us that the sum of two areas is 818 centimeters squared, and the perimeter of these two squares is 160 centimeters squared. And they have told us to find the length of the sides of the square. And the thing is, what we do is we say that there are two squares. One is square A, and one is a smaller, or you can say it's just not equal to this one. Okay, these two are not equal. So this is square A, this is square B. We say that one side of square A is x, and one side of square B is y. So what's the formula for the area of a square? Square is equals to x squared. Okay. So now we do know, or you can say in case of box B, we have y squared. So we do know the sum of two squares is 818 centimeters squared. So we can say x squared plus y squared should be equals to 818 centimeters squared. That's our first equation. And for the other equation, they have given us the sum of perimeter. So the perimeter is actually this side plus this side plus this side plus this side, meaning it's the sum of all sides. So we can say in a square there are four sides, so 4x for this case and 4y for this case. So we can say that 4x plus 4y is equals to 160. And from these two, with the help of these two equations, we are going to find out the length of one side of the square and this square also. So what we do next is we say that input, first of all, we make another equation. And what would that be? Well, that equation is x plus y. We take 4 as a common, is equals to 160. X plus y is equals to 160 divided by 4, and which is equals to 440. And we can say that y is equals to 40 minus x, and this is going to be equation number 3. So again, input equation 3 into equation number 1. So we are going to get x squared plus 40 minus x whole squared instead of y is equals to 818. Make a division here. What we do next is we say we're going to open this up, x squared plus a squared, which is 1600, minus 2 multiplied by a multiplied by b plus b squared is equals to 818. So it's simple, x squared plus 1600 minus 42 is 80x plus 60 x squared only. X squared is equals to 818. So plus x squared plus x squared is 2x squared minus 80x plus 1600 is equals to 818. What we do next is take the common of 2 to x squared minus 40x plus 800 is equals to 818. Take this to x squared minus 40x plus 800. I'm going to directly do this. This 2 is going up there and dividing with 818. So 818 divided by 2 is equals to 409. So x squared minus 40x plus 800 minus 409 is equal to 0. X squared minus 40x plus 391 is equal to 0. And this is a quadratic equation. As I promised, I'm going to only use my calculator. By the way, this one is easy. I've already solved this with the quadratic formula. And this one is easy. It's not that hard. So 1 minus 40 and positive 391 is equals to x is 23 or x is equals to 17. So these are the two sets of values for x. And then what we'll do is find the corresponding y value. So y is equals to what's y equals to? Y is equals to 40 minus x. So 14 minus 23, or y is equals to 14 minus 17. So y is equals to 17 or y is equals to 23. And as you can see, we have two different values which are the same: 23, 17, 17, 23. So we can say that the two answer is 17 and 23, or you can also write centimeter with them. So that's the answer. And the reason why we are not specifying that x is equal to 17 meter, y is equal to 23 centimeter, because we don't know. We are just going to write that x and 17 and 23 centimeter squares are there. So no need for specification. So I'm going to erase this for question number 22. So we have question which is quite similar. So y is equal to 2 minus 2x cuts the curve 3x squared minus y is equal to 3 at the point A and B. Find the length of the line A and B, as for A to B. And the thing is, let me introduce to the formula of the distance. So it's really important to know that formula before we start. So the formula for the distance is distance in a graph, is equals to under root x2 minus x1, x2 minus x1 whole squared plus y2 minus y1 whole squared. And I think it will be easy for me to explain this more clearly when we get to that point in this question. So let's first solve the question. So question number 22, we have the line y is equals to 2 minus 2x is 2 minus 2x is equation 1, and the curve 3x squared minus y squared is equal to 3. This is equation number 2. And what we are going to do is simply say that we are going to input equation 2 into equation number 1. Oh, I'm just switched up the values. We are going to input equation 1 into equation number 2. So we are going to get 3x squared minus 2 minus 2x whole squared. Let me check it. Yes, is equals to 3. So that's going to give us 3x squared minus, and in the bracket we are going to open this up, a squared meaning 4 minus 2 multiplied by a multiplied by b plus b whole squared meaning 2x whole squared is equals to 3. 3x squared minus in a bracket 4 minus 4 2 to the 4 4 to the 8 minus 8x plus 4x squared is equals to 3. So now what that gives us is we are going to open this up and simplify 3x squared minus 4 minus positive 8x minus 4x squared is equals to 3. So we're going to simplify 3x squared minus 4x squared is equals to minus x squared plus 8x minus 4 minus 3 is equal to 0. Now we are going to get minus x squared plus 8x and minus 7 is equal to 0. Switch up the negative sign so that we have a positive squared coefficient, and x squared minus 8x plus 7 is equal to 0. So what we are going to do next is, in a second, I think I have done a mistake in this question. Let me check this out. No, there is no mistake. So now what we do is factorize this up. X squared, let me take the common of 7, so 7 and 1 are the only factors. So x squared minus 7x minus x plus 7 is equal to 0, and x squared, sorry, it factorizes x minus 7 minus 1 x and minus 7. So x minus 1 x minus 7 is equal to 0. I know I promised that I won't do the quadratic equations, but still this was a really easy one, so I did it. X equals to 1 and x is equals to positive 7. So we have two values for x, and again we have to find the corresponding y value. So y is equals to 2 minus 2 multiplied by minus 2, or y is equals to, or we can say, and whatever you want to say, y is equals to 2 minus 2 multiplied by 7 is 14. So y is equals to either 12 minus 12, sorry, or y is equals to 0. And now that's where the formula comes in. So we have to find the distance or the length of the line AB. So we are going to say x2. Before that, I'm just going to write down the coordinates. So 1 and 0 and 7 and negative 2. So the thing is x2, we take the second x value 7 minus 1 minus x1 is whole square, and you have to take care that x2, whatever you have labeled in x2, the same same corresponding y value should be the y value. Okay, so I've taken 7. So for 7, the corresponding y value is -12. So -12 will also be y2. So y2 -12 minus y1 minus 0 whole square. So that will give us is equals to under root 7 minus 1 is 6. 6 whole squared is 36 plus minus 12 minus 0 minus 12 squared is going to be 144. So we are going to get under we are just going to solve this with the calculator, and we are going to get 6 under root 5 is our answer. Okay, that's it. This is question number 22. Let's proceed on to question number 23. And for question number 23, we have 2x plus 5y is equals to 1 meets the curve x squared plus 5xy minus 4y squared plus 10 is equals to 0. So find the coordinates of the midpoint AB. So I think most of you should know what's the formula for midpoint. So it's just x2 plus x1 or x1 plus x2. It depends on you. Divide by 2, and for the y value is y2 plus y1 divided by 2. It's just a simple formula. So for now we have 2x plus 5y is equals to 1, and we have x squared plus 5xy minus 4y squared plus 10 is equals to 0. Okay, this is equation 1, and this is going to be equation 2. So what we are going to do for now is update this equation. We are going to say 5y is equals to 1 minus 2x, and similarly y is equals to 1 minus 2x upon 5, and that will give us equation the equation number 3. Okay, so what we do next is we say input equation number 3 into equation number 2. Okay, and that will give us x squared plus 5 multiplied by, let me see, 5 multiplied by x multiplied by y. Instead of y, we're going to write 1 minus 2x upon 5 minus 4y squared 1 minus 2x upon 5 whole squared plus 10 is equals to 0. Now let me just make a boundary here, and let's just first simplify. So x squared plus 5 and 5 will be cancelled. They are multiplying. X minus 2x squared minus and 4. Before we do that, we are going to say a minus b whole squared. So a squared meaning 1 squared minus 2 multiplied by a multiplied by b plus 2x whole squared divided by 5 squared is 25 plus 10 is equals to 0. So what we're going to get next is x squared plus x minus 4 minus 2 2s are 4x. 4x multiplied by minus 4 will become positive 16x. If I'm not wrong, 4 4 is 6, yes. And again, plus, instead of plus minus is minus. So 4x squared and 4 4 is 16x squared divided by 25 plus 10 is equals to 0. So yeah, what we are going to do is take the common LCM 25x squared plus 25x minus 4 plus 16 x minus 16x squared plus 10 is equals to 0, because 25 is going to be multiplied by 0. Oh, by the way, this is not going to be plus 10. This is 250 here. So I know this is getting a little bit messy. Let's just quickly simplify this. 25x squared minus 16x squared is becoming 41x squared. Let me cancel the values I've already written down. 25x plus 16x is equals to plus 41x, and minus 4 plus 250. 250 minus 4 is plus 246 is equals to 0. Now take negative 41 as the common, and we are going to get x squared minus x minus minus 6 is equals to 0. So we are going to get x squared minus x minus 6 is equals to 0 is our equation, quadratic equation. I'm going to put this into the calculator. I'll get x is equals to negative 2 or x is equals to positive 3. So what next? We have found the coordinates of x, and for the y coordinates, we have the y value. So y is equals to 1 minus 2 multiplied by negative 2, which will become 1 plus 4 divided by 5, or y is equals to 1 minus 2 multiplied by 3 is 6. So 1 minus 6 is negative 5 upon 5. That will give us negative 1, and this will give us positive 1. So we have two values for y, positive 1 and negative 1. So we have found out the x and y values. We have to find the midpoint of the coordinates of a and b. So we have the coordinate of something like a. We can say that a, it's just an assumption. It's not necessary that this is going to be the a. You can also write negative 2 1 as b or a. It's up to your choice, not something else. So for 3 and negative that 1, this can also be A or B. It's up to your choice. And let me get some space here for finding out the midpoint. For the midpoint, what we're going to do is take x2 or any value we want, minus 2 plus 3 divided by 2. And for the y, we have 1 plus negative 1 divided by 2. So we'll get 1 minus 1 is 0, so we'll get 0 straight. Minus 2 plus 3 divided by 2. Put this into the calculator, we are going to get 0.5 is equal to x. So the coordinates of the midpoint A, B, you can write this MB, are 0.5 and 0. That's it. This is question number 23. Now let me raise it for question number 24. And what do we have here? The line y is equal to x minus 10 intersects the curve y x squared plus y squared plus 4x plus 6y minus 40 is equal to 0 at the points A and B. So find the length of the line AB. So it's a really simple question. Like it's nearly what we've done till now. So y is equal to x minus 10 is our first equation, and our second equation is x squared plus y squared plus 4x plus 6y minus 40 is equal to 0. That's really intimidating. So this is equation 2. This is equation 1. And now what we're going to do is find the length of AB. For that, we have to first find out A and B itself. So x and y coordinates, we have to find those out. So input equation number 2 into equation number 1. So we are going to get x squared plus, instead of y squared, we are going to write x minus 10 whole squared plus 4x plus 6 multiplied by x minus 10 minus 40 is equal to 0. Simplify this up, x squared plus a squared minus 2ab plus b squared, 10 squared is 100, not 1000, plus 4x plus 6x minus 60 minus 40 is equal to 0. Again, simplify this up to x squared minus 20x plus 100 plus 10x minus 100 is equal to 0, minus 60 minus 40. Plus 100, plus 100 and negative 100 are going to be cut out. We are going to get 2x squared minus 20. It's 20x squared or it's x? Yeah, so it's 20x, not x squared. Let me erase. It's not x squared, it's 20x. Okay, and we are going to get 2x squared minus 20x plus 10x is equal to 0. So what we can do is say take it to as common, x squared minus x squared minus 10x is equal to 0. So in a way, this can be x squared minus 10x minus 0 is equal to 0. Put this into the quadratic formula. Do not solve this directly, as that would bring your question to be wrong. So wait a second, I think I'm doing a mistake or something. Minus 20x. I do think I'm having a mistake. Okay, let me just use this up 5 the equation, x squared 1 minus 10 and 0. Let me check this out. Yes, I'm having a problem. I think I've done some error in between. So x squared plus x 4x minus 20x plus 10x is equal to 0. Okay, I got the error. The thing is, I did something wrong here. So we have 2x squared minus 20x plus 10. That will become minus 10x plus 0 is equal to 0. We take it to as common, x squared minus 5x is equal to 0. So we are going to say a is equals to 1, b is equals to negative 5, and c is equals to, well, there's nothing, so c is equal to 0. And the reason I'm solving this quadratic equation is because many people find hardness in solving this type of thing where there is no value for c. So that's why it's just an explanatory example. So minus b becomes equal to 5 plus minus under root b squared 25 minus 4ac becomes 0 divided by 2, a meaning 2. So 5 plus minus under root 25 is 5 divided by 2 is equals to x. So we are going to say x is equals to 5 plus 5, 10 divided by 2 is equals to 5, or x is equals to 5 minus 5 meaning 0 divided by 2, which becomes 0. So x is equals to 0. So we have two values of x and we have to find the corresponding y value. So y is equals to, well, we found out y is equals to x minus 10, so 5 minus 10, or y is equals to 0 minus 10. So y is equals to minus 5 or y is equals to minus 10. And that's it. Let's write the coordinates down, 5 and negative 5, and the other coordinate is 0 and negative 10. And that's it. This is the coordinate. Now what we have to do is find out the length of the line. So length meaning the distance. So again, the same formula, x2 minus x1. So x2 is 0 minus 5 whole squared plus y2 minus y1, so minus 10 minus 5 whole squared is equals to under root minus 5 squared. So minus 10 plus 5 is again 5. So minus 5 whole squared. So 25 plus 25 is equals to under root 50. And we have that is equals to 5 under root 2. If we simplify under root 50. You can just do it back input by using the calculator. Right under root 50, you'll get 5 under root 2 as a simplified version. And that's the answer. This is for question number 24. Now let's proceed for question number 25. And for 25, we have there's a straight line y is equals to 2x minus 2, which intersects the curve x squared minus y is equals to 5 at the point C. So what we are asking is, given that A lies below the x-axis and the point B lies on AB such that AB ratio PB is straight ratio, and find the coordinates of B. And that will all make sense. Before that, we have to find the coordinates A. Now, first of all, just concentrate on finding the x and y values. So equation 1 here, equation 2 over here is going to say input equation 2 into equation number 1. Okay. So if we input again, I just swap up the values. So equation 1 we have to input into equation number 2. So we are going to get as a result x squared. Yeah. So x squared minus 2x minus 2 is equal to 5. So x squared minus 2x plus 2. Remember, you have to multiply the bracket with the negative words. Many people do this mistake and they regret it later. The question becomes a mess. So x squared minus 2x plus 2 minus 5 is minus 3 is equal to 0. So use A is equal to 1, B is equal to negative 2, and C is equal to negative 3. I'm going to input this value into the calculator. So now what we do is just input this into the calculator, and we'll get x is equal to negative 1 and x is equal to positive 3. So now what we do is find the corresponding y value. So y is equal to 2 multiplied by negative 1 minus 2, or y is equal to 2 multiplied by 3 minus 2. So we'll have y is equal to negative 2, which is minus 4, or y is equal to 3 to the 6 minus 2, which will become positive 4. So now we are just going to write down the coordinates in a simplified version, minus 1 and 4, and positive 3 and 4. So these are the two coordinates, and now let's proceed to the next part of the question. So they are saying that given that A lies below the x-axis, meaning that this is the x-axis, and they're saying that the point A lies below that, meaning the y value is negative. And we'll see which y values in these two coordinates you see is a negative. Obviously, negative 4 is the negative y value. So we are going to say the point A is negative 1, negative 4, and the point B is 3 and 4. And before let me explain the rest. Now they're saying that there's this line, this going something like this, okay? And they're saying there's a point B somewhere here, and this is the point A, this is the point B. They're saying this is the point B. We have to find the x and y values of this, and we do not know. So this straight line. Now, and they're saying there's a ratio of 3 to 1, meaning from A to this point, meaning A to P, we have something like 3 if we divide this, and from P to B we have something like 1. So we let me introduce to you a new formula. So this is the formula of internal division, and you have to like literally learn it by heart. So what is the formula? The formula is m1 y2 plus m2 y1 divided by m1 plus m2, and for the x value we have m1 x2 plus m2 x1 divided by m1 plus m2. And what these m is referring is not the gradient, it's referring to the ratio. So 3:1 is equals to m1 ratio m2. So the ratio is actually the m's. So, m1 is ratio 1 and m2 is ratio number 2. So that's what it is. So we can say these m values are actually the ratio. And let me clear some space so that I can solve this out. So for the y value, we are just going to input the values. Okay. Okay. Now the thing is, we have two y values. We are going to say for value of y, we are going to just input the y2 and y1. So m1, what was the m1? m1 is 3. So m1 3 multiplied by y2. What's y2? We are going to assume this as 4 as y2. So 3 multiplied by 4 plus m2 is 1 multiplied by what's y1? It's going to be negative 4 divided by m1 plus m2. So 3 plus 1. Simplify this. 4 3 is 12 minus 4 divided by 4 is equals to 8 divided by 4, which becomes positive 2. So we have positive 2, which is the y value. And for the second thing, for value of x, we are going to say m1 again 3, x2, what's x2? It's going to be 3 plus m2, which is 1, minus x1, which is the x1 minus 1. So 1 multiplied by negative 1 divided by 3 plus 1, m1 plus m2. So we are going to get 3 is 9 minus 1 divided by 4. So 8, that will be 9 minus 1 is 8. 8 divided by 4 is 2 again. So the coordinate of P is going to be 2 and 2. Okay, and that's it. And that explains why formula makes life a lot easier. I mean, these formulas make your work time literally 10 times less. You easily solve your questions without any delay. And that's the thing. You pause the video, copy down that equation, and learn it. And it's really important for everyone. So we are done with question number 25. What we do now is question number 26. This is going to be the last question. For question 26, we have x minus 2y is equal to 2. And this line intersects the curve x plus y squared is equal to 10. Again, equation 1 and equation 2. Before we start, let's find out what they have told us to find out. So we have to find out the equation of the perpendicular bisector. Okay, and put this in the back of your mind. First, find the x and y values. Okay, first find point A and B, and then I will explain what and how the perpendicular bisector works. So what we do is x is equals to 10 minus y squared. We're going to say this is equation number 3, and we are going to input equation number 3 into equation number 1. Okay, now what we get is x minus, sorry, so we'll get 10 minus y, 10 minus y squared minus 2y is equals to 2. Simplify this, minus y squared minus 2y plus 10 minus 2 is minus 8 is equals to 0. Take negative as the common, y squared plus 2y plus 8 is equals to 0. So y squared plus 2y plus 8 is equals to 0. That's it. What we'll do next is y squared plus 4y minus 2y minus 8 is equals to 0. Y plus 4 minus 2 y plus 4. We need a positive here, otherwise when this would multiply we would get a negative, so is equals to 0. So y minus 2 y plus 4 is equals to 0. So y is equals to positive 2 or y is equals to negative 4. If you don't know how we got positive 2 and negative 4 out of this, non-maths. So for the corresponding x values, we are going to say x is equals to 10 minus 2 squared meaning 4, or x is equals to 10 minus negative 4 squared meaning 16. So negative 16. X is equals to 10 minus 4, which means it's equals to 6, or x is equals to negative 6. Now that's done. We have two coordinates, 6 and 2, and this is coordinate A or B, whatever you want it to be, and the other coordinate is negative 6 and negative 4. And before we start with anything, let me explain what a perpendicular bisector is. So we can say perpendicular bisector, for example, this is a line. This is y is equals to 1 minus 2. This is a straight line. Whatever. Don't take the equation. This phrase, I don't know what gives a straight line. So this is the equation of the straight line, and this is going straight. The perpendicular bisector is the thing or the line which intersects the line, divides it into half, and makes a 90-degree angle at the point of intersection. That means there are two sets of rules for a perpendicular bisector. First, when it intersects at a point, it makes a 90-degree angle at that point, and secondly, it divides a straight line into a half. That's the two rules for a perpendicular bisector. And before we go on, everybody knows what's a tangent. And if you don't know, for example, we have a curve, and at this point, line is going and just brushing this point. It's just touching that point. This is called a tangent. And what I'm just overviewing this tangent is not that important. What is of importance is a normal. So I've got an image to explain that. And as you can see, this is the tangent of a line. It's passing through this. It's a red line here. It's passing. This is and just touching a point of the curve. This is the tangent. And the normal is actually the thing which makes a 90-degree angle with the tangent itself. And that's the thing. We can say that if we find out the midpoint of our line, and at that point we find out the equation of the normal, we can find the equation of the perpendicular bisector. Okay, and there's a rule connecting the equation of a normal of a line. So for example, this is a straight line. We can say that y is equals to, or you can say the normal gradient is equals to, gradient means m, it's a short form of gradient, so negative 1 upon m of line. So whatever the gradient of this line comes, if we what can you say, reciprocate this and put this into a negative value, we'll get the normal grade of the the gradient of the normal. And that's the thing. Before anything, we know that this perpendicular bisectors divides the line into two. So we need the midpoint. Okay, we are going to act from the midpoints. So for the midpoint, what I'm going to do is erase this all, and first of all, find the midpoint of our equation. So where is the midpoint? Midpoint is going to be 6 minus 6 divided by 2, or in fact, or for the y values, and minus 4 plus 2 divided by 2. That's going to give us the midpoint is for the x value it's at 0, and for the y value we have minus 2 divided by 2, which means negative 1. So we have the midpoint. The midpoint is x is equal to 0, y is equal to negative 1. Okay, and before that, we need another thing. We need the gradient of the line. So m is equal to y2 minus y1 minus 4 minus 2 divided by x2 minus x1 minus 6 is equal to negative 6 upon negative 12. Cut down these negative values. 6 1 the 6, 6 2 the 12. So we get minus 1 upon 2. Sorry, positive 1 upon 2. So this is the gradient for our straight line. And I've discussed that the gradient of the normal is minus 1 upon m of the gradient of the line. So we can say reciprocate this. If we do that, we get 2, and turn that positive value into a negative value. So multiply positive by negative, we are going to get negative 2 is the gradient for the bisector, or you can say bisector, perpendicular bisector, p dot bisector. Okay, and now the thing is, let me erase some more. It's more conceptual, by the way. So, and now what I want to know is, let me erase all of it. So the thing is, we have the gradient, and we also know that whatever a perpendicular bisector is, it's a straight line. So we can say bisector, perpendicular, it's going straight line. Okay, it's going and making a 90-degree angle. So we obviously know it's going to be a straight line. Okay, it can be at some tilted angles, something like this, but the thing is, it's always coming in a straight line. So we can say it follows the equation y is equal to mx plus c. We can say this is the base equation for the perpendicular bisector. So what we do is we have the y value for the perpendicular bisector, meaning the midpoint, because it divides the line into two. So we take the y value negative 1 is equals to, we have the gradient negative 2, we have the x value which is 0, and plus c. First of all, we have to find the c as you have guessed. So minus 1 is equals to c, because negative 2 multiplied by 0 is 0. So we have the c value, we have the gradient, we have the x value, and we have the y value. So why not? We are just going to write y is equals to, instead of the gradient, we are going to write negative 2 x plus, instead of c, we are going to write negative 1. And that's the equation for the bisector. Negative 2x minus 1 is equals to our answer. This is the equation for the perpendicular bisector. And that's it. This is for exercise 2.1. And yes, I'll meet you in the next section, exercise 2.2. Okay, thank you for watching.